welcome to the DPP Success webinar. File-based workflow represents a big change in how broadcast facilities will be structured. A major step forward is happening right now in the UK because of the DPP initiative. Starting on October 1st of this year, UK broadcasters will accept video content only in file-based form that conforms to the DPP requirements. Today's webinar will prepare you for this change. Here's our agenda. We're going to go through some areas that will help anybody who is trying to deal with the coming change in file-based delivery requirements, COPE. First, we're going to talk a little bit about why the DPP is important. Second, we're very excited to have a conversation with Ian Bushaw, a DPP gatekeeper. As head of digital media at Deluxe Media in London, his organization is under contract with several UK broadcasters to ingest their video content. Come October 1st, when the DPP requirements take hold, it will be his job to accept or reject files destined for UK broadcast clients. His unique perspective will help us all better understand what we need to do to comply with the DPP requirements. After that, Simon Pegg, Senior Software Pipeline Architect and DPP Workflow Lead at RadiantGrid, will look at the archiving DPP compliance, at achieving DPP compliance with a look at the technical side of what it will take. After that, we'll take live questions from our panelists. And finally, Craig Newbury, VP at RadiantGrid, will describe a new RadiantGrid solution. So let's just take a look at our speakers on the next slide. Here's our panel of speakers today. I'm Josh Gordon, president of the Josh Gordon Group, and we will be here to answer your questions. You can answer questions of any of these folks in the lower right-hand corner of your webinar interface. During this session, all phone lines except for those of the speakers will be muted, but by typing in your questions, we will see that they all get answered. So if we're going through the webinar and questions occur at any time, please feel free to type in a question while it's still fresh in your mind. We'll aggregate those questions, and toward the end of the presentation, we will answer them all. All right, on the next slide, we'd like to talk about why DPP is so important. Well, this is the list of UK broadcasters who are involved with it, and you can see they're pretty much all of the majors. And the DPP, or Digital Production Partnership, is an initiative formed jointly by UK broadcasters to help producers and broadcasters maximize the potential benefits of file-based digital distribution. And on today's agenda, we'll cover the areas facility managers need to comply with these new requirements. So on our next slide, we're going to take a look at why DPP is important. By mandating that all video content between UK content providers and broadcasters conform to a specific file-based format, the goal is to improve efficiency for all participants. Al Kovalik, a well-known US-based workflow consultant, simply describes how this benefits everybody. Everyone who touches a file has an advantage over the complexity of having a lot of different file formats to not only send but receive. Once files are standardized, everyone deals with a common input, common ingest, and common QC. And because we're not dealing with a wide variety of media, everyone gets better at what it does, and hopefully errors go down. Also, cost savings can be achieved by eliminating the expense of tape, both at the output and input level. Maintaining a battery of different kinds of tape machines, of course, is costly, and if all we have to do is output and receive one kind of file, costs go down for everybody. But this is not the only issue that UK and broadcasters everywhere are facing. If we look at the next slide, we can sort of see that further down there's another issue. Broadcasters are being confronted right now with a pivotal issue. A lot of younger viewers are tuning out of traditional broadcast channels and instead logging online and accessing video content via the internet, so-called cord cutters, as they call them in the United States are millennials, typically ages 18 to 34, who have largely tuned out of traditional broadcast channels. It's largely thought that the way broadcasters can combat this issue is to take advantage of utilizing their content to launch alternative online channels, basically participate in the multi-screen world of the future of broadcast. And as we see on the next slide, the DPP initiative is actually a pretty critical area for that sort of thing. Because once broadcasters can take advantage of metadata contained in the files themselves, it becomes possible to automate a lot of processes and create many more channels of content much more quickly. If we see the next slide here. Okay. All right, there we go. Okay, so anyway, basically, when all of the files can be ingested and shared together, it's possible to create many more channels much less expensively. Okay, and that basically concludes this section. Let's move on to our next section, which is a conversation with a DPP gatekeeper. Ian Bushow has a unique perspective as head of digital media at Deluxe in London. I'll be asking him a series of questions to bring out his unique perspective on the DPP initiative as a gatekeeper, but please keep in mind that you can also ask lots of questions as well by typing them in to the interface in the lower right-hand side of your webinar. So let's get started. Ian is live with us, and Ian, the DPP requirements will make the lives of your broadcast clients easier during content ingest and save them some money. But DPP is a big, unprecedented initiative. Is it really worth all this effort just to save a few pounds at ingest?
Hi, Josh. Well, whilst any time and cost savings are obviously welcome in this industry, and especially at the moment, the DPP initiative is more about removing the proliferation of formats, of standardizing deliveries, and therefore workflows which I guess would simplify downstream processing and help regulate quality.
Yeah. Some are saying that the DPP initiative is really about the continued survival of broadcast. Is that overstating the case?
I think that's perhaps a little overstated, but in the UK it's fair to say television advertising revenue was traditionally a share between only a small number of commercial broadcasters. And of course in this new multi-platform world, revenue spread rather thinly, so it is in the broadcaster's interest to try and find efficiencies and cost savings, as well as investigating new revenue streams.
Okay. Let's put this into perspective, just how big a change this is. From a technical point of view, DPP mandates that all video content be delivered in file-based form. Ian, at your facility, how long ago was it that a majority of the content you received was tape-based?
I suppose it's fair to say it's been over the last 2 to 3 years we've seen that happen. We saw the deliverables of going from file to tape tipping over the 50% mark at about the 2 to 3 year mark. However, since then, the progress of migration to file-based delivery has been accelerating, and now we receive a very significant amount of material as file-based media, and almost all of the material leaving Deluxe for UK broadcast is file-based. And of course, on October 1st this year, UK broadcasters are only going to accept file deliveries.
Wow, okay. All right, so you've been getting in a lot of different files, and it's not quite October 1st yet, but of the files you've received so far that were rejected, what was the most common problem?
Well, AS11 is a ratified AMWA format, and of course a large number of manufacturers are able to produce compliant files. DPP builds upon the AS11, so issues with creations of the files themselves are generally rare. However, the significant difference between the AS11 spec and the DPP shim of it is the inclusion of a 16-byte metadata space that needs to contain appropriate information. This is where we see most failures here, such as mandated fields not being populated, incorrect information entered. There are other issues, of course, such as using incorrect DPP shim version, audio channel configuration issues, lineup, MXF structural issues, but predominantly it's metadata.
Okay. All right. Now, Ian, you're running a facility whose job it is to pass or fail DPP files according to the requirements of the DPP specifications, how do you actually do that? What happens at your facility when a file arrives?
Well, as a general rule, material arrives on our landing pads and is initially processed through a basic file check simply to ensure we've received the correct format. We'll then run the material through an automated QC sequence that includes metadata extraction and validation, loudness measurement and testing for flashing images. This is followed by a spot check on the file, which allows us to review the reports and the metadata as well. And although the process does not guarantee to catch every possible issue, we found it's pretty robust. For suppliers regularly providing material, we're looking into the process of implementing a trusted status regime for suppliers, where after initial testing period has been successful, we'll sign off that supplier, but perhaps more importantly, their process chain into this trusted status. So if anything changes, for example, the supplier updates their Transcode or software, then the testing process will need to at least be partially repeated to ensure they stay in that trusted status.
Okay, that's great. Now, we're not quite at October 1st. You know, we still have a little time before the requirements go into full force. How tough are you on video content coming in from overseas? Do you evaluate content from within the UK where people are very familiar with the DPP standards?
DPP is obviously a standard, and therefore there can be no relaxing of the rules. Either material meets the standard or it doesn't. In the case of material coming in from overseas which is not correct, but is still in a usable form, let's say has metadata issues, we can and have in the past made corrections, especially if deadlines are tight against transmission. But this usually results in us passing a charge to broadcasters who then on-pass that back to the supplier.
So on October 1st, what will change?
Well, at the moment, in the UK, broadcasters are accepting DPP files or tape as a fallback solution. But on October the 1st, that fallback solution is being pulled away from under their feet, and it's going to be DPP compliant files only.
Wow. Okay. Now, Ian, you get a lot of video content heading into UK broadcasters from around the world. I'd just like your take on how much awareness you think there is of DPP outside of the UK.
Well, interest is definitely growing in DPP, and it's a standard that's being driven by the business needs of end users rather than previous attempts where equipment vendors have been driving it forward. This, DPP stands a good chance of a focused implementation. And I know for sure that major studios in the US have become involved, with the likes of Disney and Fox now able to produce the formats. And we are currently working on a US shim of the AS11, the AS11NA, which is broadly similar to the DPP, albeit at differing frame rates and so on. So interoperability is not necessarily going to be great there. Other countries such as Spain, South Africa are all watching DP progress with interest, and I believe Norway's NRK have recently adopted the format.
Okay. All right, I've got just a few more questions for Ian here, but again, I'll remind you folks out there in the audience, you can ask Ian a question as well, just by typing the message into the lower right-hand corner of your webinar interface. Ian, I'd like to take a step back here and have you give advice to a facility who's looking at starting to output DPP files for the first time. Now, it seems that the requirements of a large facility that outputs, dozens or hundreds of pieces of content would be very different than, say, a small post house which may output only a few a week. Why don't we start with the low output facility? What should they do first?
I think for the lower volume producers, it's a more simple process. Most of the main non-linear editing tools can now export DPP shim AS11 files. Even if they're not capable of doing that, they are likely to be able to produce AS11 files, which can then be processed using the wonderful free DPP Meta-data application to create compliant files with the inclusion of the required metadata.
Okay. But for high volume facilities that produce dozens or hundreds of pieces of content, the requirements are different. What advice would you give them?
Well, that's kind of where we find ourselves. We're processing a lot of material, very high volumes of material, and the challenge we're finding is to be able to find a cost-effective way to produce and deliver material. A number of Transcode vendors can create DPP shim AS11 files, but the real challenge here is to populate the metadata fields with information, ideally through an automated process where information is harvested from the MAM systems, file interrogation systems, and then wrapped up automatically during the file transcode or transwrap stage prior to dispatch to broadcast. In both cases, either in the small and the large provider, audio also needs to be compliant to EBU R128, and QC and PSE checks have to be performed as close as possible to the delivery point.
Ah, great. Thank you, Ian. All right, that concludes my questions for Ian in this section, but I would encourage you all in the audience to think about a question you might want to ask Ian, because he's going to be sticking around to the end of the webinar where we're going to have a Q&A section, and he'll be there to answer any of your questions. Right now, I'd like to shift the webinar off to our next presenter, who is Simon Pegg. Simon is Senior Software Pipeline Architect and DPP Lead at RadiantGrid. And there's no smarter man in the room than Simon when it comes to the technical side of these standards. So, without further ado, I'm going to introduce Simon, who is going to talk through achieving DPP compliance, the technical case.
Thanks, Josh. So if we're talking about DPP compliance, I suppose the first question we need to answer is, what are we actually trying to comply with? And you've already heard some discussion about AS11. AS11 defines a generalized MXF format for program contribution. It has a number of options in it. It really needs to be constrained more tightly in order to provide a sufficiently tight specification to allow interoperability. And that purpose is served by the DPP shim. The DPP shim is actually currently defined inside the AS11 document. It's currently the only shim defined in AS11, although there is work underway, as Ian's already mentioned, on an AS11 North America shim as well. That shim limits some of the options that are available in AS11 to give you a very tightly constrained binary definition of what an AS11 DPP shim file can be. That really only worries about the binary content of the deliverable file. The next document that you really need to pay attention to is the technical standards for delivery. And we've just had to edit these slides because as of about 2 hours ago, the version of that document changed from version 4 to version 4.1. The good news is that the technical content of 4.1 is identical to 4. It's just got some clarifications on some of its wording, but that is the latest document that you'll see. That technical standard for delivery takes the whole process of producing that content and describes the constraints that are placed on that. So rather than just concerning itself with binary, it talks about things like quality requirements, limitations on acceptability of certain cameras, things like video constraints, audio constraints, and PSE testing.
Okay. Simon, of these, for typical users, which is most important? Which of these two documents is the most important standard?
I mean, generally, as an end user, you'd hope that your primary concern would be with the technical standards for delivery, which is, is kind of the relatively, it's broad, but it's relatively high level. The AS11 and the DPP shim documentation is as I say, it's very technical. It's down at the binary level. It references several SMPTE specs. That's primarily there for people who are developing tools that deliver AS11 and DPP shim files. Hopefully, as an end user, if your toolset's doing the job correctly, you should never really need to dig that deep. If you're still in the early stages and you're looking at trying to decide which tools to go with, or if you're already delivering and you want to understand perhaps some of the problems that you're having, then it might be worth having at least an awareness of the AS11 and the DPP shim documentation.
Okay, good.
So now we know what we're trying to comply with. There are 6 key areas. We call them the 6 pillars of DPP compliance. And we're going to go through each of these in a bit of detail. So the first area is timeline, which is actually how your content is laid out within the file. Then we'll look at some of the video requirements, the audio requirements, talk about compression, how that file is then wrapped into the MXF file, and finally, and very importantly, we'll talk about some of the metadata requirements that are associated with delivering a truly compliant DPP file. So, if we look at, the first thing to say is if you're trying to deliver a DPP file and you already have that content on tape, it's probably not sufficient to just take your tape content, ingest it, transcode it to a binary compliant DPP file and submit that to the broadcaster. That's probably not going to get you where you need to be. The technical specification for delivery is quite prescriptive about how content is laid out, indented, lined up, and everything like that on that within that file. And so you need to be aware of the layout constraints that are being placed in it. If we look at this example first, this is just a single piece of program content within one file. So we're starting off with our program element. The next requirement then is that we have to wrap around that. We have to put some black before it. The length of that black is specified in the specification. We have to put some living hold or some black at the end of that segment as well. And again, these times are all specified in the technical delivery specification. Those are there so that we can make sure that we can cut in and out frame accurately, or if we're not cutting frame accurately, that we're not going to trash clocks and things to air.
Can someone just use their standard clock or slate for DPP?
Yeah, so in fact, I forgot to mention, beyond that black at the beginning, you've also got a clock element. Okay. Again, the technical specification for delivery is very prescriptive about that clock. That clock has to be circular, it has to be an analog style clock, it has to have a hand that ticks, i.e. non-smooth motion, and it also specifies what information must and may not be on that slate. So for example, you have to have the production number of your product, of your content on that slate, but you can't have any technical data. You can have some contact details. Okay, so you really have to look at the spec and make sure your slates are compliant with that.
It's very specific.
Yeah, it is, very much. Moving on to the next level then, the actual ident, the first part of that file that you're delivering has to have an ident, sorry, the lineup on it. That lineup in terms of video is going to be EBU color bars, so they're 100% saturated color bars, and syncty bars are explicitly not acceptable, so you're going to have to redo your lineup at least. On the audio side, as we'll see later on, the specification is specific about how you lay out groups of audio. Your audio lineup has to match up with the layout that you've selected, and you also have to tie that into some metadata that goes into the file itself. Basically, there are two different types of audio that are in there. One is stereo, one is multi-channel. If you're going multi-channel audio, then you need to have what's called blitz, and we'll talk about blitz in a second. And if you're using stereo, then you need to have EBU 1K tone, and again, we'll just talk about that quickly. One thing that's worth looking at is that the times that are shown on that diagram, so the lineup, the slate, the black times, and the hold times, are all specified in the specification. And there are two versions of that specification. One version, which was part of the original specification, and is more aimed at compatibility with tape, where you typically have relatively long lineup and clock sections, and the newer or short version, which came in with version 4 of the specification.
So we've got two versions of the specification, one the current and one the legacy. Can people use either one?
Well, I mean, technically, they're both still part of the specification. So in theory, you can. I would certainly be sure to seek approval of the particular broadcaster before I delivered some content with a legacy lineup.
Okay.
So we just to cover, I said we'd look at the 1K tone and the blitz. If you look at the top two blue lines on this, that's showing the audio waveform for 1K tone, to give you an idea. You can see in the top channel, which is the left channel, there's a little break. That's a 250 millisecond gap every 3 seconds. And that's just used so that at the other end, if someone's listening back to that audio, they can tell that you've got the left channel in the right place. Okay. If you then come down and you look at the next block down, there's 6 channels there. This is now EBU blitz. So here you have, I mean, you can see just looking at in the time domain like this, that each of those signals is unique in terms of its pattern. There's also some frequency content in there that's unique to each channel as well. So again, someone at the other end, or even an AQC process, can analyze that audio and confirm that the channel layout is as it expected to be. And if you want to know a bit more about either of these tones, then you can look at EBU Tech 3304, which is the document that specifies them. So that was looking at a simple single program content in a DPP file. The next area that's worth considering is where you have hard-parted content. And that's content where you actually have the main program broken editorially into parts. So you might have specifically broken that program at a given point. You might have a coming up next section. You might have a previously it's the sort of thing where you couldn't tie all those parts together and make it look like one single seamless program. It'd be obvious that there were breaks in it. When you're doing that, you then have to lay that content out in your MXF file in a very particular way. The first thing is that there is, obviously you've got you still apply to the rules of the hold time at the end of each part, but you also now have a minimum time between the end of your first part and the start of your second point. Your subsequent parts all have to start on minute boundaries so that they're easier to kind of dive to straight away. Optionally, you can employ the same kind of slate and black lineup, ident at the beginning of each part as well in that process if you want to, but it's only required for the first part of a hard-parted program. It's optional for the subsequent parts.
Okay, and speaking of taking a break, let me just interject here that you can see that Simon has a tremendous amount of knowledge to share in this area, and I'd encourage you to type in a question for Simon, which we will get to toward the end of the presentation. Simon?
Thanks, Josh. So now we're going to start looking at a bit of a we're going to work through a typical workflow for preparing and delivering a DPP compliant file. So if you look at the top of this, start of this flow diagram, we'll build it up as we go. That green box there is coming off the back of your NLE when you think you've finished your edit. The first thing you're going to have to do then is go into a kind of a human QC stage, if you like, which is generally referred to as the eyeball check. So the eyeball check is really looking for artifacts that can't readily be detected by automatic QC tools. Things like incorrect captions, poor quality grading, or blanking errors.
Can't blanking errors be detected by automatic QC tools, though?
Well, actually, blanking errors originally were being worked on as part of the AQC process. But I was looking at some of the DPP work that's still ongoing in terms of the AQC side of it. And that's actually been, if you like, relegated or promoted to an eyeball check now, because the current state of the available tools is that nothing yet can successfully tell the difference between a blanking error and something black parked on the edge of frame, which might be completely valid. And the problem is, at the moment, all of the AQC tools generate far too many false positives, so that's been pulled back as an eyeball check. There is something that we're still better at doing than machines. Typically, if something is causing a failure at the eyeball check stage, you're going to have to go back into your NLE and use an editorial fix to address that problem.
Okay.
So just adding in the next stage, once we've got past that eyeball check stage, typically we then go into a preliminary AQC or automatic quality control stage. So this is a machine, some software, analyzing where we are with our content and identifying the sort of things that are perhaps difficult to spot if you're a human doing that check. The classic here would be photosensitive epilepsy. So the technical specification for delivery specifies that any content must be delivered with a photosensitive epilepsy test pass certificate. If you go onto the DPP website, there is a list of the tools that are accepted as being of sufficient quality and accuracy to do that. Your preliminary AQC may also check things like loudness on the audio or video gamut on the video side to optionally turn on additional downstream processing if you need it at that stage.
Is the preliminary AQC really necessary? Presumably you're going to have some kind of final QC process.
Yeah, I mean, you'd be foolish not to have a final QC. I guess the point of having an AQC up front is that you pretty much from here on you're going to go into transcode. Transcoding to ABCI 100 is time consuming. You don't really want to burn all that time and then go through all the subsequent process before you hit your AQC, only to find that there was an error that you had to go back and provide an editorial fix for, because basically you've then burnt the whole of that workflow time. So doing some preliminary checking here can help you save time in the long run.
That makes sense.
So if you like, the left-hand side of the picture is the stuff where you're primarily looking at editorial fixes. On the right-hand side, we're more into the kind of automated and technical side of things. So typically, having got through all your video preliminary AQC, the last thing you want to do before you hit transcode is to do things like gamut processing. So the technical standards for delivery specifies the classic EBU gamut, which is plus and minus 5% in the RGB domain, minus 1% and plus 3% in the luminance. So all your content really has to go through some kind of gamut control process. And ideally, you'd look to keep that in the file-based domain. Sometimes you can do that in an NLE, sometimes you can do it as part of your transcoder software. Sometimes people are having to resort to doing that in baseband simply because they can't deliver the quality of gamut control or the performance on that gamut control to work within their flow. That was video. Let's talk a little bit about audio. So the technical specification for delivery is very prescriptive again about how you can deliver audio. Basically, HD audio, generally 16 channels. The layout that's permitted is restricted to a small set of the channel allocations that are defined in EBU R1 of 23. And probably the most standard DPP HD audio layout would be what we're showing here, which is 16C. So down the bottom of that slide, you're seeing the 16 audio channels. You've got 2 sets of stereo and 2 sets of multi-channel audio. If you're starting from the point of having a multi-channel audio mix, so that's your final program, and you also have a multi-channel audio just mix and effect, you can see how those are then processed in the case of the mix. So we have to loudness correct that mix before we insert it into the 6 audio channels that are allocated to it. On the multi-channel audio mix and effect stuff, we can just plug that straight in.
Okay. Now, what do we do if the source material is only stereo?
Okay, actually, you jumped slightly ahead of me.
Oh.
We'll come back. So that's fine. I'll come and I'll talk to that in a second.
Okay.
Let's just look at the stereo channels first. So if you're looking at the stereo channels, additionally now for our main mix, we're actually having to do a down mix and then loudness process again. Okay, and just to clarify, this actually where it says loudness, technically at the moment that either loudness or normalization. The technical standard for delivery currently permits audio to be delivered either normalized against a BBC Type 2 PPM meter, which is kind of old school, or preferably loudness processed to EBU R128 with a minus 23 LUFS target. So you can already see that just building a standard R123 16C audio layout, we've already got 4 different processing paths for audio, just creating that one set of audio. Now, if the source material is only stereo, then there are also a 4-channel variant as well. So you can use R48-2A, R123 4B, and R123 4C. The 48-2A is just 2 channels of stereo audio and 2 channels of silence. The 4B and 4C are 2 channels of main program audio and then either music and effects or audio description. And if you're not familiar with audio description, we use that over here as part of our kind of access services. It's for visually impaired people, and effectively allows us to produce an audio commentary over the top that describes bits of the action that are going on that might be missed by someone who is visually impaired. So kind of subtleties that are significant for the plot of the program. Right.
Okay.
And the reason, if you're wondering why you don't have to normalize the music and effects tracks, that's because the normalization or loudness rules within the technical standard for delivery only apply to finished program audio, and the music and effects sections are not considered finished program because they're going to be typically used for overdubbing later on. So they would have to be normalized or loudness processed before they went to air, but at the point of delivery you don't need to. That was audio. So sorry, I'm getting kind of slow, I think. So going back to my transcode workflow, that was I'm now looking, having prepared my video, prepared my audio, I'm now ready to go into the transcode stage. So the next thing we need to look at, and we're going to look at this very briefly, because most people should be vaguely familiar with it, and it can get a bit dry and technical, is the compression side of things. So typically we're talking here about AVC Intra 100, because that's the HD requirement. The thing to watch out for here is that AVC Intra 100 needs to be SIMT RP 2027 compliant, That's actually a further constrained definition of ABC Intra 100 that's used for as part of the SSD specification. It just has a more tightly constrained set of rules applied to it. And also from the DPP shim, there is a constraint that requires us to have SPS sequence parameter set and a PPS, that's picture parameter set, on a per frame basis. So if you're doing long GOP content, typically you have one per GOP. Because this is iframe content, historically you could either have one right at the beginning of your sequence, but on the DPP specification you have to have it per frame. That's so that in theory your file can be taken and someone can jump into that file at any point and they'll have all the information necessary to decode from that frame onwards. It also has the effect that it makes all the frames physically the same size, so it's very easy to sequence through that file very quickly if you're trying to search to a particular point. On the SD side, the one to watch out for is that it's 720/608 at 50 Hz, so it's got 32 lines of VBI as part of your image, but that VBI has to be blank. You're not allowed to have any data in there or any picture content, and that's going to be D10 or IMX50. Once you've got it transcoded, we need to wrap it up. And what I'm really showing here is that AS11 has some requirements, and the DPP shim has some requirements. And because the DPP shim constrains things more tightly than the AS11, it's entirely possible to produce an AS11 compliant file which won't ever be DPP compliant.
Wow. Now, this slide and the last one are pretty detailed technically. Is the average end user going to really need to concern themselves with this level of detail?
I mean, hopefully not. If your tools are doing the right thing, and hopefully the tools are guiding you through the process of delivering these DPP files, you shouldn't have too much of a problem. But equally, talking to Ian's saying, typical examples of some of the failures they're getting are things like partitioning. Okay, well, AS11 defines a default partition size of 1 minute with a maximum partition size of 10 minutes. But actually, when you look at the DPP shim, that says you have to have a single partition for the whole program. So there you've got the DPP shim overriding, and if you're not aware of that, then you might be confused when your tape gets rejected because of a partitioning error. So it's certainly worth having an awareness of, even if you're not kind of beat down in it every day.
Okay.
So we've done transcode, and now we're getting into metadata, which is really important. There are 3 main types of metadata that are going to be in this DPP file, and that's descriptive, technical, and segmentation. And we're going to look at each of those now. So your descriptive metadata describes what your content is at a kind of human editorial level rather than at any kind of technical level. And AS11 itself has a core set of descriptive metadata. It's very concise, shall we say. That's pretty much it on the screen there. The DPP shim then extends that metadata schema with an AS11, what's called UK DPP schema. And that adds in a lot more descriptive metadata about stuff, things like contact information, when the product was actually finished, that production number which needs to tie into the production number that's on your slate, all those kind of things. The next level on from that then is we're looking at technical metadata. And technical metadata actually breaks down into 2 different types. There's one type of technical metadata which we call structural, and that's data which describes the technical construction of the file, but which doesn't have an explicit metadata existence in the file. You don't put it in as metadata. It's inherent to the file. That's things like frame rate and video codecs. So you don't need to worry about those. The next type is the stuff you actually have to put in. And again, AS11 has its own kind of core technical metadata. Again, it's comparatively light compared to the DPP stuff. I suppose the biggies on here are things like shim name and shim version. They weren't in the original version 1 of the AS11 specification. They were added as part of 1.1. Some tools have been, it's taken a while for some tools to kind of catch up and insert that data. So make sure your tools are inserting shim version. And then probably the audio track layout is probably the next most important. That ties back into your audio structure. You need to make sure that the audio you're delivering and the metadata that describes it match up. We then come down into the UK DPP metadata, and again that extends it still further. Important ones here would be the information related to PSE, so photosensitive epilepsy. You need to make sure that when you've done the test that metadata gets inserted into the files correctly, along with the manufacturer and the version of the tool that did the testing. And also loudness standard, that describes whether you've normalized against PPMs or loudness processed. The final kind of metadata is what we call segmentation data. And this is defined in AS11, but it's optional within AS11, and it's mandatory within the DPP specification. And basically, once we've laid out our content on the timeline correctly, there are bits of that timeline which are intended to go to air, and there are bits that aren't. And the bits that are we call segments, and the bits that aren't we call filler. And we have to create within that MXF file a metadata timeline track that runs the whole length of the content, and at every frame effectively describes whether that content is considered filler or considered a segment. And that means you can take a DPP file, and with automation you can immediately seek to the areas that you know you need to play to air without having to actually go off and read some separate report that tells you where all the timecodes are. It's inherent within the file. It's worth noting that when I was looking at the DPP website recently, and they'd just done a workshop, and they were highlighting that it's timecode and clock inaccuracies that account for a significant amount of failures that people are seeing. So it's worth getting a handle on all this stuff. So that's kind of the metadata done. Final stage we talked about earlier is probably the AQC stage. So having done all of that work, you're pretty much going to want to plug this in and do at least a confidence check at an AQC level. This is potentially, this is mainly looking at metadata, the compression, and your wrapping compliance. But you might also optionally need to run a secondary PSE check, gamut checks, and loudness checks. Depends on how well established your stream is. Once you're pretty established, and maybe you're on something like Ian's preferred supplier route, you might be able to tone down some of the checks in the final AQC. But certainly initially you probably want to run them. And then you take that AQC report and you deliver that along with the file that you've produced to your broadcaster. There are some moves within the DPP at the moment to try and potentially in the future get to a point where the results of that AQC actually get embedded directly into the file. So again, everything's tied to a single file that you're delivering. So that's kind of it really. We've gone relatively quickly and lightly through those 6 key areas. None of what I'm talking about actually should be too hard. Some of it can be quite tedious. The most important thing is to have an awareness of the requirements that are being placed on you, to plan for those 6 areas, choose your tools and your workflows accordingly to make sure they're going to make that work for you as easily as possible, and then you should find that actually this big switch to DPP delivery is not such a big deal.
Okay. Thank you, Simon. That was a terrific, detailed summary of what it takes to create compliant files in the DPP standard. Now we're going to ask some questions here of our 2 panelists here. Ian is still with us, and Simon is as well. We have some questions that have come in during our session. I'm going to read them off. Here's the first one. What happens if I cannot create DPP files, but I have to send materials? Ian, you'd probably be best to answer that one.
I guess so. That's going to be a discussion between the supplier and the broadcaster. This isn't a hard wall, I don't think. We're yet to see exactly how it's going to be implemented. Obviously, if broadcasters over here have purchased material or want to purchase material for broadcast in the UK from other territories, and they are not capable of producing that certainly straight away, then it's going to be a discussion between the 2 of them. I'm sure they're not going to blanket block people if they don't, but that's certainly what they're aiming towards.
Okay. Simon, here's a question. I know you go to all the DPP meetings there in the UK. You mentioned a DPP Meta-data tool. Where can I find this?
So if you go to the DPP website, which is www.digitalproductionpartnership.co.uk, and you go to the download section, you'll find the link to it in there. And basically, once you've got a binary compatible AS11 file, DPP shimmed, you can open that in that DPP tool, and that will allow you to both view and also edit all of the metadata that's associated with it. And then once you've done that, you can then save that back out the other end.
Okay, great. Okay, here's another question here. Will Will a program mixed to COM loudness specifications be okay for DPP? I'll let either one of you who wants to take that one.
I would say, sorry, do you want?
No, go for it, go for it.
I would say no, for the simple reason that the COM specifications have a different loudness limit. They have -24. Although strictly,
although it's fair
strictly
to point out
-24 is tighter than -23, yeah.
Yeah,
I mean,
so the stuff we've looked at that's COM, since the gating has come in COM, so the silence gate, if you like, has come into the COM in the last iteration, we've found that a simple level change by a dB or two, sorry, a lux or two, will actually bring it within R128. But Simon's quite right. On paper, it's not. They're not exactly compatible.
Yeah, I mean, actually, Ian's got a good point as well. So technically, the COM specification is -24. The R128 is -23. The tolerance on that -23 is too big, really, for you to get away with -24. But the nice thing is that if you just applied a 1 dB shift, you'd actually be pretty much bang on the money on that -23, and you'd probably be well within spec.
Okay. Here's another question. Can metadata be provided using an XML file alongside a standard AS11 file?
That's an interesting question. That's not the first time something like that's come up. In the previous iterations of the DPP format, it was mandated that metadata be carried in a sidecar XML to accompany the DPP shim AS11 file, which, from a personal perspective, that was great because those XMLs we can use to trigger material to be auto-ingested. So, for example, if Disney were sending us a file over here for UK broadcast, they send the file first, followed by the media file first, followed by an XML, which carries all the metadata, and the arrival of that XML would trigger a whole automated process which would populate the man with all the data out of that XML and all sorts of stuff. And importantly, within that XML, you can carry the MD5 checksum. Now, that mandate has been removed in the latest versions of the DPP format for reasons we perhaps won't go into here. But the result of that is we have had to modify automatic landing pad processing. But probably the most important thing is we no longer have a valid MD5 checksum. Now, within the DPP payload of the MXF file, there is still a space to put the MD5 checksum information. But of course, the very process of writing that into the MXF wrapper invalidates the value of that figure. So we're quite happy if people want to send those files alongside still. That's useful information to us. But still, an AS11 file, if it isn't DPP shim, will be rejected.
Okay.
And if I can just kind of add into that, there is also, so in the early version of the DPP specification, there was this definition of a sidecar XML file, which Ian's talking about. One of the problems that has caused stumbles for a few people is that sidecar's gone away, but some broadcasters still refer to a sidecar XML. The problem is it's not the same sidecar XML as was defined in the DPP. So, for example, Sky have effectively a manifest XML that they expect to be delivered with their file. It actually doesn't contain the DPP metadata. It contains some B-Sky-B specific metadata about that program. And a bit like Ian's just said, I think they use it to trigger downstream processing. So you need to be a bit aware that not all sidecar XMLs are equal, if you like.
Okay. All right, we have another question here. I do not have a file transfer system or decent connectivity. Can I deliver files on a hard drive?
No, please. Yes and no. Yes and no. It's a difficult one, this one, because in theory, you can stick your DPP file on a really nice, robust hard drive, stick that on FedEx and ship it over the Atlantic. But that's prone to failure. We try and steer people away from that. We have had a number, admittedly a small number, but a number of files that have failed due to that. And what we suggest is if people absolutely have no other way of doing it, then give us a sidecar, well, not an MD5 along with the file so that we can verify what you sent is what we've received. However, again, that's a discussion perhaps for the providers to have with the broadcasters, because the broadcasters, and in fact Deluxe ourselves, we can provide ways of delivering files. Would be both for an enterprise systems that we can provide simple links in an email that people can start uploading from. The real constraints around that would be what the bandwidth availability is at the sender's end. But there's always way to avoid hard drives if you look hard enough. We really try and avoid it.
Okay. Ian, facilities in the UK, such as Deluxe, I was curious, would people be able to talk to them about helping pre-check materials in the early days of sending content to UK broadcasters? Are UK facilities generally open to this sort of thing?
Yes. It's early days yet, and I don't want to use this platform to sell our service particularly, but it's something we're looking into because there are a lot of small producers out there who have been happily making tapes for years, and all of a sudden they're finding themselves in a very strange place, and they perhaps haven't made many files at all, let alone DPP-specific ones. So yes, there are a number of post-production houses. I'm sure there's a few people looking at the list of attendees here who are thinking the same things, who are willing to offer that service, effectively of making a DPP file from whatever format you've got and getting it into a transmission facility.
Okay. All right. Well, thank you very much for those questions. We're now going to shift over to the final part of our presentation. Craig Newbury, Vice President at RadiantGrid, is going to talk through a new RadiantGrid solution.
Thanks, Josh. So it's clear that there are a number of challenges to overcome in delivering DPP compliant workflows. I'm going to take just a few moments here to introduce a new solution from Weller Technologies, which is based on the powerful RadiantGrid Intelligent Media Transformation platform that allows our customers to produce files that support the DPP standard. So firstly, let's take a look at a typical workflow of the type of processes that many of our customers that we talk to have to accommodate. It's a workflow that has a number of touch points, difficult to automate fully, and has a number of human interfaces. And as we've seen and heard through this presentation, as we move towards delivery formats that are increasing in volume because of the proliferation of multi-platform delivery, and which are becoming more tightly constrained, it's becoming more and more important to our customers to be able to move towards a reliable, repeatable, and perhaps most importantly, a scalable solution which can be automated as far as possible. So in order to address these forthcoming challenges and to allow media facilities to begin taking advantage of the efficiencies and advantages of a truly file-based solution, Weller are introducing a new appliance solution powered by RadiantGrid called Weller DPP. Now, Weller DPP is a one-box solution designed to simplify a DPP delivery workflow and offers support for all aspects of a DPP file creation workflow. It supports the 6 key areas of DPP file creation that have been talked about through this presentation. The first being audio loudness, where we leverage linear acoustic algorithms for superior 3-pass measurements and correction to EBU R128. And we can increase throughput using our unique parallel processing capabilities. Our unique and specially engineered right hue video legalizer provides best-in-class processing at the point of transcode, and that eliminates the need to drop into baseband processes, which we see quite typically, or for our customers to have to wait for time-consuming NLE renders. Our quality control interface provides an integrated support layer for a range of devices, including VidCheck, Serify, and Baton, and allows our customers to be able to verify and validate both the file format and the wrapper for conformance. Metadata support includes both read and write capability and supports the 3 DPP metadata schemas. It also includes the ability to drive a workflow according to that metadata, which is important for a lot of people. Additionally, as
as we were just talking about a little earlier, there's support for sidecar metadata generation, and that supports legacy DPP implementations, and also allows those customers who wish to drive an external metadata workflow to do that. Now, Roller DPP naturally supports high-quality encoding and decoding of the DPP prescribed ABC intra for HD and IMX50 for SD formats, all in an AS11 wrapper. But it also supports a range of other useful codecs which can be used for things like proxy generation or creating mezzanines such as ProRes or DNX HD for use within the facility, pre or post DPP format delivery. And all transcoding on our platform benefits from RadiantGrid's unique TrueGrid capability for super accelerated processing and transcoding. The included assembly engine within the platform provides an automated metadata-driven mechanism for both creating and then stitching elements such as black, bars and tone, and slate with the program content. Now, as you can imagine, this hugely simplifies the correction of libraries for older non-DPP compliant master assets, for example, and it also removes the burden on a traditional NLE system. Now, of course, all these things in isolation are great. In combination, they represent an enormous amount of capability, but it becomes incredibly powerful when they can be automated easily. That's where the DPP expert system comes in. That provides a lightweight data interface to drive a complex Roller DPP process easily, and importantly, in conjunction with any existing automation or traffic systems our customers may have. So in summary, Roller DPP saves our customers time and money by reducing overhead for multiple workflows and reducing the requirement to maintain multiple devices. It eliminates the need to hop between different processes, that is, go between different devices to be able to achieve different functionality. And it also enables genuine scalability by removing the need to drop out to baseband, the use of time-consuming NLE processes, and it also increases throughput enormously. Now, if you're interested in seeing the solution for yourself, we'll be exhibiting at the BVE exhibition in London at stand K30. We'll also be running a DPP surgery with some of our partners in London on the 4th and 5th of March, and we'll also be exhibiting at NAB in Las Vegas in South Upper 4410. You can also search for some information on the internet by typing Roller DPP, and information can be gotten from us by emailing us at sales@roller.com. Thank you.
Thank you, Craig. Okay, we do have a few questions that have come in. Let's see, Ian and Simon, are you still on the line?
I'm here, yeah.
Yeah, I'm still here.
Great. Let's see, here's a question that came in. Does DPP affect live TV broadcasting, or is it only applicable to pre-recorded material being sent to UK broadcasters?
Shall I fill this one, Josh?
Sure.
So actually, the DPP was all the broadcasters coming together to agree common standards, and actually the first thing they did was to agree a common tape standard before we even got into file delivery. The current DPP specification includes common requirements for file-based delivery, tape-based delivery, and also live delivery as well.
Okay. Here we have another question that came in. Just to clarify an earlier reply, the DPP tech.del.spec does include sections for live broadcast.
Yeah, that's someone basically saying the same thing that I've just said.
Okay, very good. Okay. The other question, which we've been asked several times, is how can we access this webinar online? And it will be posted on the RadiantGrid section of the Roller website. So it will be posted soon, and anyone can access it, review the information, or send a link to friends to also watch the webinar. That concludes our presentation for today. Thank you very much for sticking by us through our early technical difficulties, and sorry we went over a little bit late, but we did start late, so we more than made up for it, I think. But thank you very much, and good luck with your DPP requirements. Thank you.